Afternoon, everybody, and thank you for joining us for AMGC Connect's Optimising Your Manufacturing Operations. We'll probably have a few people drifting in, but we'll get things underway. So thank you for taking the time. If we could have the next slide, please. So just a little bit about AMGC. AMGC, or the Advanced Manufacturing Growth Centre, is the peak body representing small to medium-sized Australian manufacturers. In our capacity with the Industry Growth Program, we're offering a range of support services, including these webinars. If I could have the next slide, please. Those services at a variety of levels start with our one-to-one engagement. One-to-one is facilitated through your business advisor, and there's a range of supports we can offer there. We will also be running a range of one-to-few activities, and these can be access to facilities to assist you in your commercialisation of your products and services. We'll also be looking to leverage the collective knowledge of the manufacturing industry and bring small groups together to talk about your pain points and pinch points and learn from people that have already lived that journey. And then one-to-many events such as the webinar today. We can have the next slide, please. So today we're honoured to be joined by Dr. Michael Lucas. Michael, who's sitting to my left here, has over 30 years experience in robotics, automation and manufacturing optimisation. His CV reads like a who's who of businesses, but for the purposes of this, Tesla is probably the one that comes to everybody's mind, a company that leans in heavily on automation to achieve the results they do. But he has worked across clean energy, food and beverage, biomedical, renewable energy, and many others. Michael stood up and founded a business called Manufacturing Catalyst with the express aim of helping people make things make them better. So without any further ado, I will pass across to Michael to get this webinar underway. If you do have any questions as we progress, please drop them into the chat box or the Q&A field, and we'll address them at the end. Thank you, and over to you, Michael.
Thanks, Tyson. So normally people want to optimise their manufacturing operations for a range of reasons. You're adding or you're scaling a product, or you want to improve your profitability through quality and yield, or you want a reduction in end-to-end costs, or you want to improve your sustainability both economically and through your energy and material use. And it doesn't matter whether you're assembling something, fabricating something, processing something, reacting something, or distributing something, or the scale you're currently at. The basic ideas of optimizing to allow for efficient scaling to the right production output are essentially the same. If we go to the next slide, this is essentially what I want to go through with you today. It's all about making the right amount of the right product in the right place at the right time. We're going to talk a little bit about where I've come from to get to this. I want to bust some manufacturing optimization myths, because there are some things going around in some of industry that we can jump through, and then we'll talk about some why, some when, and some how, and some key takeaways, and then we'll have some Q&A. We go to the next slide. These are the places where I've been involved in products or processes and factories around the world. If we jump to the next slide, several $1 billion worth of projects in some brands that you probably recognise. There's a fair chance that a product or manufacturing process that I've been involved with is something that you've consumed sometime in the last week or so. If we move to the next slide, we'll start with busting some manufacturing optimization myths. If we move to the next one, the first myth is that the most important thing when optimizing is buying the right equipment and software. And this is something that's perpetuated by people who sell equipment and software. But it's something that is not necessarily always the case. I've got an example of a prefabricated construction company that I did some work with, who had been quoted a substantial sum of money and quite a bit of time for automation and robotics to help replace their manual operations, and it would have disrupted them for many months. Instead, all they needed was some jigs and fixtures and some better ergonomics for their people, and they were able to reduce both cost and increase production, quality and safety. And they were able to then take the same philosophy to their other production lines for their other products. And what they're able to do is optimize that without necessarily spending an enormous amount of money on replacing the equipment that they currently had. It's a good reminder that there are more robots on the planet Mars than there are in the average Australian manufacturing facility. We go to the next slide. Instead of focusing on equipment and software, there's three things that I like to get people to have a think about. It's their people, their product, and their process. If you've ever seen any of the Lean or Six Sigma information, that's what they will look at. But perhaps look at this in a different way. Your people on your factory floor, the people in your offices, your customers, all understand your product in a way that if you interrogate that the right way, you can find out some information about how you might be able to improve your product or your process. If you look at your product, there is almost always a way to make that simpler or more optimal for manufacturing. A good example from the chemical processing industry was a company that, in scaling from what they were doing as enough to be able to supply the New South Wales market, when they wanted to supply the global market for that, they suddenly discovered that they were going to need 3 Sydney harbours worth of water every year to be able to do that. And obviously that's not a sustainable way of doing things. So they were able to go through a design for manufacture of their chemical product and figure out how to use a lot less water in that. If you then also look at the process, this is where you will probably make most of your gains in being able to optimize things, is optimizing the process. And there is no point in investing money in software or equipment until you've fixed your process, because then unless you've fixed your process, all you're going to do by adding software and equipment is make a bad process go faster, which is not a good, long term, that's not good for optimizing things. If we go to the next slide, the one piece that's always missing off the people, process, product triangle is data. Depending on where you are in your manufacturing journey, you should have some data, mainly about your process, but probably about your people and your product that you can interrogate to look further into that. And we'll get to that in some of the other conversations later. But if we go to the next slide, our myth number 2 is that you need to measure everything to start to optimize your manufacturing operations. Now, measuring is important, and to paraphrase Peter Drucker and W. Edwards Deming, you can't manage what you don't measure. But you can do it in a staged approach. It doesn't have to be all or nothing. If we go to the next slide, one of the biggest optimization projects I've worked on is for this electric vehicle company here. Now, if you look at the 6 vehicles on that screen, there are thousands of parts from suppliers in hundreds of locations in several countries, and the product and the production lines continued to evolve. If we'd waited until we could measure everything before we started optimizing, we'd never have started. So instead, we quickly triaged and ranked what was able to make a difference, part by part, and measured that in detail, and then moved down the list. The measurement activity for each thing remained in place until that component or process was designed out. Now, that's an extreme example with thousands of parts across a fairly diverse supply chain. But it doesn't matter what scale you're at. If you try and measure everything at once, you'll never get to a point where you have enough that you can actually start with. So I always like to say to people, pick the thing that is causing you the most pain or has the most upside, and start with measuring that, and then work your way down the list, and then you can generally find things that are relatively easy to implement. If we go to the next slide, this is related. There is a myth that you have to optimize your entire facility at the same time to get an acceptable return on investment. And similarly to measuring everything, you don't have to fix everything at once. Again, what's causing you the most pain and what has the best upside? If you were to look at your facility, what is it that is going to give you the best return? You don't have to do the whole lot at once. One of the examples on the next slide is fairly well-known international food manufacturer who were looking at their Australian manufacturing and distribution operations. they figured to be able to make their overall manufacturing supply chain easier, that they were going to have to optimize at about 8 different points around the country. What it turned out was that they found one piece of their national distribution centre where they could put in one robot and keep everything else the same, and they were able to make a substantial improvement. And that's because they've gone for the one thing that is causing them the most pain and where there was the most opportunity for some upside. If we go to myth 4 on the next slide, that you must standardise everything to succeed is a myth that's perpetuated again by automation and equipment and software suppliers. Now, I love standardised products and processes. They're really easy to work with, but they don't represent what a lot of Australian manufacturers actually work with. It doesn't matter whether you're a contract manufacturer who has multiple customers' products, or someone with a product that has variants or is undergoing rapid development. Standardisation of everything is often impossible, but it's often recommended by automation and equipment vendors because it makes their job repeatable and easier. If we go to the next slide, one of my favourite examples of things that you would think are standard but are non-standard is the humble pallet. Most people think a pallet looks like this. They expect it to be perfect. If we go to the next slide, this is more what a pallet looks like. It's got some real world level of wear and tear. I'd like to say that pallets are a bit like fingerprints. No two are the same. One of the optimization projects that I worked with for CHEP, the pallet company, was to develop an automated inspection and repair system so that they could repair more of these pallets every day. We were able to repair up to 600 pallets per hour using this automated inspection and repair system 20 years ago. None of their international competitors have been able to develop a comparable system because their way of thinking was constrained by thinking that every pallet was absolutely identical and standard and it had to be returned to perfect condition to succeed. All the difference was that we had made it return it to what was acceptably standard. So why should you change your successful product just because your vendors won't think outside of their box? With that said, if you're embarking on an optimization journey, it does give your team the opportunity to review the products you're making or moving to ensure that they are optimized for their entire journey through the supply chain from raw materials to your end customer. At a macro level, a pallet is standard enough that the millions of uses it gets put to every day don't need to worry about its variation. Think about your product. Where can you draw the line as to what can be standard and what can vary on your product? Where does variation matter and where does it not matter? And that goes back to what we were talking about with measurement. Perhaps one of the things that you want to measure is variation. Perhaps some of that variation is acceptable and it would just be a consumer of your time and money and energy to fix a thing that doesn't necessarily need to be fixed. If we go to the next slide, myth 5, is that manufacturing optimization projects always take a long time to implement. Manufacturing optimization projects will always take forever because you should always be optimizing what you do in your manufacturing process. However, it shouldn't take very long to be able to see the fruits of some of that investigation. If we move to the next slide, and this is again my experience with the electric vehicle company over in the US. Famously on the news, there was a production line that was built in 3 weeks. Now that happened to be the first 3 weeks I was working with this company, and we built a production line in a tent in a car park in 3 weeks. Now, to be fair, we had a bunch of equipment that we could reuse to make that happen. But the upside of that was that we now had a test bed where over the next 3 to 6 months, we were able to optimize and learn about all the things that we could do without necessarily impacting the existing production. So we were able to get more vehicles out without changing what we were doing. What we were able to learn from that, though, was that the next production line that we built in the building that's in the main photo was now much more straightforward than any of the 3 that they'd built previously in that building. And then when we built things in China, in Texas and Berlin, those lines were even more simplified. But all of that came from that 3 weeks of experimentation and figuring out what we could do better. And it's then permeated through the way that they do things forever after. So the piece that I take from that is that even in a really large organisation, you can do some very quick experimentation after you've done some of that measurement to figure out what you might be able to do to optimise. And it doesn't have to be big. It could be a single piece of equipment. It could be a single feature on your product. It could be a way that you're getting it to your customer. It could be a way that you're getting your raw materials in. If we go to the next slide, I like to recommend this book. If you've not read this book by Ben Flugberg and Dan Gardner about how big things get done, this is a good way of thinking about how to make any project, but an optimization project fits into this beautifully, take the appropriate amount of time and cost you the appropriate amount of money. So yes, the myth that it takes a long time to do optimization projects still persists, but there are ways that with a little bit of clever thinking, you can make sure that you can get consistent benefit out of that. Now, we'll move to the last of the myths, which is that the maximum capability of the system is defined at the time you purchase the equipment. Now, this might be equipment that you're about to buy. It could be equipment that you've had for many years, and now you're thinking that you need to do something different. If we move to the next slide, which thanks to the AI generated images here, but one of the things that I want you to take away from this is that if your systems have been enabled by software, the software can now grow in capability. If your systems have people in them, the people will always find better ways to do things. We go back to that people, product, process from earlier on. All of your operators, I would call them cleverly lazy. They will always want to find better and easier ways to do things. All of your technical teams will come up with better ways to do things. Your product design teams will come up with better ways to do things. So the people are the secret sauce in making sure that a lot of your existing investments can grow and be improved. Processes can always be optimized. I've never come across a place that has perfect processes. Almost every place ends up with adequate processes, but are they perfect? No. But there's always room for you to optimize any of your processes, and that could be at a macro level. It could be a process is a whole bunch of things happen to your product at a certain point. It could be right at a micro level that I'm moving an O-ring from here to here. If I move it a shorter distance, I can do it faster. And you can also evolve your product to require less steps. One of the things that I always like to recommend to people is that if you haven't put your product through a design for manufacture and assembly analysis, then it's worth doing that as a starting point, because if you look at your product, I guarantee that most of the products are able to have something improved on them. Maybe that's a feature that can be combined with another feature, or something can be removed, or something can be added that makes it faster, cheaper, easier to manufacture. So those are the 6 myths that I encounter when I go and talk to people about optimizing their processes, that seem to be embodied in a lot of what Australian industry thinks, it's difficult to optimize because of all of these things. One of the things I'd like you to take away from this is that optimization is something that everybody can do, and you don't necessarily need to have lots of expensive equipment, lots of expensive software, or lots of expensive experts come and help you to do it. It's something that you know your products and process and market better than people from outside your organization. So that's a really good place to start, is with the information that you currently have inside your organization. So I'm going to move to the next slide. I'm going to talk to you about a little bit about why, when, and how you might optimize your manufacturing operations. So let's go to why. So go to the next one. So some of the common reasons that you might want to optimize would be quality and yield issues. Perhaps your facility is space constrained. Perhaps you need higher productivity to remain competitive. Perhaps you have an aging workforce or difficulties hiring the right people. Perhaps your energy costs are too high or your material costs are too high. And these are the things that are stopping you from remaining competitive. Perhaps you're on a journey of scaling from something that's at a lab or a prototype, and you're able to do it with some seasoned experts, but now you need to scale it to a size where you need to be able to do that much more efficiently. The quality and yield issues in this one are, can we go back? Yeah, so quality and yield issues are something that tend to be really, really obvious. Your customers will complain about quality. Your production manager will be upset about when they've got to throw some things away because your yield from your production is not good. Again, the facility space, you are going to know that you don't have enough space. When I mentioned the prefabricated construction people earlier who were able to not invest in lots of automation and robotics and were able to rearrange their space, one of the upsides of that was suddenly that they had more space to move around in. Where they thought they were going to have to move to a new facility, they were able to stay in their existing facility and make more space to be able to produce more. If you've done a market analysis about what you need to do to remain competitive, a lot of the time that's going to come down to what people will refer to as productivity. Now, that may be the traditional measure of productivity of how you're getting things, productivity per person hour. It might also be energy productivity or water productivity or those sorts of things. And one of the things I think a lot of Australian businesses struggle with at the moment is hiring the right people. A lot of small manufacturing businesses have a workforce that's been with them for a long time and are potentially entrenched in the way that they do things. And this perhaps gives you an opportunity to think about how you could optimize to make it easier to attract new people or to keep the people that you currently have. Let's move on to the next slide. When should you optimize? Well, I always say that yesterday was the perfect time to optimize any process, but ideally, get started this afternoon. It's something that you should start thinking about. If you're here listening to this presentation, it means that you have an interest in optimizing what you're doing. And I would say start to think about when you can start thinking about optimizing now. What are you going to optimize? How are you going to do it? What are the things that you need to measure to get there? So if we go to the next slide, some of the questions that you should be asking yourself and your production team and your operations teams, has your product been through a design for manufacture analysis? We mentioned this earlier, but it doesn't matter what your product is. Most people think for design for manufacture is all about assembling things. I've gone through design for manufacture processes with food companies, with chemical companies, with traditional manufacturers, that the ideas that you look at, how are you going to manufacture it? How do you make your manufacturing of that product simpler? That, again, is reasonably universal in the way that you look at that. Now, you may want to do that internally. You may want to get somebody who is a design expert to come and assist you, depending on what your product is. We talked about measurement before, but one of the things that I would ask myself if I was optimizing processes in my manufacturing business was, is my process well defined and measured? Now, it doesn't need to be measured down to every last piece of this, but have you mapped out your process? It's amazing the number of successful manufacturing companies that I go to who want to optimize, but they can't describe, other than walking you through the factory and saying, Bill does that and Mary does that and Jane does that, they don't have a good map of what their process is. So if you've defined your process, then it gives you things that you can look at measuring. The next thing I would ask you to consider is, what's the investment over time and does it fit your schedule and budget? So when do you need to have things optimized by? If you're a market leader, perhaps there isn't a time frame that is a deadline, but perhaps you can see competitors coming up behind you that will give you a time frame of when they're going to be more competitive with you. What's your budget for doing this? I said before that you don't need to invest in equipment or software as the main thing, but at some point you may need to invest in some equipment and some software. You may need to invest in some new people to be able to do some of these things. I would also ask you to think about, will this optimization give you a step change versus competitors? If it's not giving you a step change versus competitors, are you actually optimizing the right thing? Perhaps you need to optimize it for other reasons. Maybe you need to optimize it for environmental reasons, that you shouldn't be using particular chemicals, or you shouldn't be importing things from a certain part of the world, and that's why you want to optimize. But for the most part, one of the reasons to optimize is to give you a step change versus your competitors. One of the other questions that you should ask yourselves as you go through this is that, do you have the people to manage and operate any new processes and systems? So if you're going to change the way that you do things, can your existing team do that? Or do you need to hire different people or additional people to be able to do that? And do you have a plan about how do you work with that? How do you do the change management with your existing people to get them into new systems? And how do you go about looking for the right people if there's a gap in what you've got? Make sure that you factor that into all of your thinking as you're optimizing, because the best optimization in the world will fail if you don't have the right people to make sure that it is successful and continues. And those 5 things, while you would think about them as you start to optimize, I'd encourage you to make sure that they're things that you continue to look at, as optimization of your process and product should be something that is an ongoing continuous improvement for you. So make sure that you're thinking about these and checking in with yourself about these things. If you're introducing a new product, make sure that before you do that, you've figured out how has it been designed for manufacturing. Make sure that you can define and measure your processes, think about the investment, think about what it means against your competitors, and think about your people, and do that as a continuous process. Let's move to the next one. How are you going to go about this? Well, it'd be really lovely if you could turn the dial from manual to automatic and it would just happen and optimize. But unfortunately, you're going to have to put in some work to be able to get to the point of optimization. So if we move to the next one, here's some key checkpoints that I would suggest that you go through as you go. Now, some of these I've spoken about previously here, but let's go through them one by one here. Make sure that you've examined and measured your processes, but don't get bogged down in trying to do them all at once, because you'll end up with analysis paralysis. Find the ones that are going to make the most difference. So start with the maximum value add or the maximum cost differential. And they're doing those 2 things together, examining and measuring your processes, and then ranking them and triaging them, and starting with the ones that you're able to make the biggest difference at, will give you the practice that you need, that by the time you get to the smaller ones, those should become really easy. Again, this one will probably sound obvious, but look at your supply chain from end to end. It's amazing how many people think inside their own 4 walls and not how many steps up the supply chain of where their parts or materials or raw materials come from, and how many steps they need to go through before they get in the hands of your end customer. So think about everything from your raw materials to when your product gets in the hands of your end customer, and how that relates to everything that happens inside your 4 walls. So while what's in your 4 walls is under significantly more control by you, you can make some decisions about things that make the rest of that easier. So how do you distribute it to your customer? If perhaps you've been able to make more space in your in your manufacturing facility, perhaps now you don't need to go through somebody else's distribution system to get things to your customer. Perhaps that still makes sense. Have a look at where your components are coming from. If you've got components that are coming from the far side of the world, but you can buy an equivalent component locally, what does that do to your ability to meet your customers' demands and to be able to change and optimize quickly? I would tell you to question absolutely everything, whether that's experts or vendors or your own internal things. Remember that you will always understand your business and your product better than anyone that comes in externally to try and sell you something. So think about, if someone's trying to sell you something, is it the right thing for your business? So make sure that you are asking the right questions, that perhaps there is a different way to do things. Perhaps you don't need to spend megabucks on an automation installation. Perhaps you just need to line up your processes and your current manual stations, and you can make enough of the right product to be able to satisfy your market or to satisfy a future market. Make sure that when you're going through any optimization project that you have really tight project management. Who is responsible for making sure that the process is measured, that you've done some experiments to figure out what an improved way of doing that might be, and they might just be thought experiments. You may not have to build anything, but and then who's responsible for implementing it and keeping it going, and making sure that there's the change management for the people. So make sure you've got really tight project management around that, because you may come up with the best optimization in the world, but it may fail because you don't have the people managing that to make sure that it continues. And the last of the points that I would ask you to have a think about is that I'd suggest that you take a systems engineering approach. Think about what's your test plan. How are you going to determine that the optimization has actually been beneficial to you? There have been a number of companies that I've worked with who have been through endless continuous improvement processes and have ended up essentially in the same place they've started, because they've not actually had an ability to figure out what it is that they can do to test that their optimization has improved. So take those as a whole. Look from end to end at everything that happens in your supply chain, at all of your processes. Start with the things that make the biggest difference. If you get experts come in or others come in to assist you, question what it is that is being done there. How can they help you? But also question everything that you do and that your people do. Perhaps there's things that while you're close to it, people are too close to it to see, because they do what they've always done. Make sure that you've ensured that the optimization project continues and that you're able to implement everything, and make sure that you can test it to ensure that that you have actually achieved what you set out to achieve. And I think those are the takeaways that I would give the group here, is that optimizing is something you need to do. Every business should be optimizing what they do. You should really take a look at how you do it, but don't be frightened that you have to do everything at once. Don't be frightened that you need to spend a lot of money on a lot of equipment and software. There are things that you can do and investigate that can get you along the path to a better way of doing what you do. And have a think about what your market is and how much should you be making. Perhaps optimizing something is making less of something. And a lot of people think that optimizing is enabling you to make more. Perhaps you may need to be making less of one thing and more of another thing. So have a think holistically. I hope that's been helpful, and happy to answer any questions that people have.
Thank you, Michael. I'll let you stop to take a sip of water. And just to prove that he is an expert in optimization, Michael was given the brief of 35 minutes and he's landed on 35 minutes. So with that, we will ask people to put any questions they've got in the Q&A box, and I know that there are a couple up there now that we'll just bring up. So, Michael, this is a question from Jeff. You mentioned prefab. Australia has a housing crisis and manufacturing residences, homes, looks like the most inefficient process imaginable. What should we do?
Oh, awesome question. So if you go to the average building site, they are doing all sorts of things that if you were to try and do them if you were to try and do what they do on a building site in most factories, it would be shut down for any number of reasons. But if you look at what they're trying to achieve, it is essentially a manufacturing process. I'd like to think of construction as manufacturing without the roof. So if you look at prefabricated construction and modular things, perhaps there's some regulations that might need to change to make that work. But there are already several companies around Australia who are very good at making, say, a modular bathroom that you could drop into a hotel building or an apartment building. You may not be able to drop it into a house yet, but you can do that. One of the things that people talk about when they look at prefabricated construction is they say, well, it's great for, they look at what perhaps has been done in China and Southeast Asia, where they've built big buildings quickly by using manufacturing techniques. And they say, well, it's great for things that are all the same. And I take you back to the myth about things needing to be standardized. That if you look at what you're doing, perhaps the standardizing is around how the plumbing or the electrics are done and making sure there's some structure there. But with a flexible manufacturing line, if you look at the average white goods line that's making different washing machines and so on, they're able to make multiple different products on the same line. There's no reason why you can't do the same from a manufacturing perspective for different houses or different buildings. And so there is really an opportunity in the manufacturing industry to optimize the construction industry by taking what we've learned as manufacturing companies and applying it to their industry.
Thanks, Jeff. We've also got some other questions that are coming in. So, Phil, problem with prefab is often modularity isn't taken into account to start with, which is kind of to Michael's point. Start with a solid modular section design that can interact easily and reliably. I think that was just a point from Phil back to the question earlier. So please, if you have any questions, feel free to put them in the chat box. We may just move to the next slide. While we're waiting for some questions, Michael's details are up there. As part of AMGC's Connect program, Michael Lucas is available to support your commercialisation journey. I'd ask you to talk to your business advisor if you'd like to tap into Michael's knowledge base as part of AMGC Connect. But Michael, I think the one thing that jumped out to me while waiting for some potential questions to come through is that optimization should take forever, because you should always be optimizing. And this lines up with another quote that I know, which is, today's advanced manufacturer is tomorrow's legacy manufacturer if they fail to advance. And the two seem to go hand in hand. You should always be looking to stay at the forefront where you can. To you, what is the lowest hanging fruit that you see at the present in terms of things that people could address?
I think there's a few things. That making sure your people are able to do what they need to do is fairly high on that list. You'd be amazed at what the people on the factory floor can contribute if you listen to them. And some of the best advanced manufacturing I've seen has come from legacy manufacturing, where the operators had decided, well, if we were able to do this and this and this, that would be amazing. And they've taken that back to the engineering team, who've been able to go, we can make that happen. So I think that's one set of low-hanging fruit. The other is just making sure if you've got everything defined, you will know where you've got problems.
Going back to the people piece, cleverly lazy. I love that, because at the end of the day, people will try to do things the most efficient and least energy expended way. And it mirrors something that we've experienced with another manufacturer that was looking to automate quite a manual process. In doing so, they deployed cobots, but the person that helped them program those robots was the person that was doing the program manually before, and then they were upskilled to be responsible for the management of said cobot later on. Are you seeing people lean in on that, where people are slowly moving from the production floor into those higher skilled areas where they're actually the perfect person for that role?
Absolutely. I think one of the things I mentioned earlier about Australian manufacturing, a lot of companies have an aging workforce problem. The nice thing about having an aging workforce problem is that you've got decades of experience. And a lot of those people have learnt things before the technology was available to be able to do particular things. So they know things that the smart young kids putting in fancy robots don't necessarily know. If you can put the two sets of capabilities together, I think you end up with a really amazing outcome, because you've got the people who have, provided they've got the right attitude, they've seen things, they've learnt things, they know what does and doesn't work for them, and they're able to then translate that as they upskill. And so you get the best of both worlds by tapping into the people who've got that previous experience.
Also, I think when I've had the pleasure of walking facility floors and you look at people and go, oh, we've got this robot, or we've got this machine, or we've got that machine, and that machine is actually nearly 80 years old. That whole concept that you talked about early on, that you don't need to spend a lot of money to find efficiencies, and newer doesn't always mean better. I was standing in a manufacturer the other week that had a lathe that was 85 years old, but it was still pumping out product as it did from day one. Is there advice to people that are sort of at that cusp of stepping up their production capability and capacity? Do they really always need to go out and buy something new? Or is a couple of hours of your time may unleash a whole range of savings on both ends of the spectrum for them?
So I think that's a really good point. You don't necessarily need to go out and buy something new. There is a really good chance that what you've already got, particularly if you've been doing things for some time, is actually really, really awesome. You're just not getting the best out of it. Perhaps with that 80-year-old lathe, they could look at how do they feed it and how do they take product out of it. And maybe that makes something that was invented well before computer-controlled machines were around equivalent or better to one of the newer machines that can do that. So perhaps there's, in a lot of cases, I look at what are the gems of uncovered gold that you've got in your existing operation, that with a little bit of optimization around it, perhaps that then becomes the powerhouse that drives the next stage of your manufacturing journey.
Okay, great. Look, I'll ask Michael one more question from my end, but please don't hold back if you do have a question. We're happy to tackle it. Otherwise, we might wrap this up shortly. But another anecdote of having the pleasure of walking the floors and engaging with industry is optimizing for climate. We had a primary producer of fruit that used a cobot to pick and pack. So off they were going, and said machine was only operating at 50% efficiency because it kept overheating. Their solution was to buy a second robot.
My solution would have been to find a fan.
So again, it's a really good example of that really simple outside set of eyes on a particular problem where you get buried in the detail might just be the one thing, and a $20 fan may have been it, or a cooling system developed for it for the region. It's
also amazing when you look at some of the manufacturing facilities that now have decided that they need to invest in air conditioning for their people. Perhaps all they needed to do was open the doors and keep the dust down, and they could have made equal improvement for their people's ability to operate, whether it's people or equipment. If you think about the environment they're working in and what's important to keep them operating efficiently, maybe there are some really simple things you can do.
Excellent. I've just seen a question coming from Phil again. Sorry, we missed that. When it comes to fabrication, when is it worth switching from a supplier to an in-house production for things? For instance, moving from automotive to aerospace grade parts, there's a need to track bolts, etc. From the billet to the fitment, which is much harder when it comes to logistics.
Awesome question. I think one of the things is that you should think about what's your key value add and what's your core competency as a manufacturing company. If you're building drones or ag tech machines or something, perhaps it's not in your wheelhouse to go and manufacture the printed circuit boards. Maybe you need to go and get an expert to do that. When it's something that is regulated, whether it's a defense or biomedical, perhaps there is a really good reason that you should stick with buying things from people who are efficient experts at it. On the other hand, perhaps you've got something that you've got a product that is quite different to other people's things, and you can't find anybody who makes the thing that you want. Maybe that makes sense for you to now go, well, I'm going to make my own printed circuit boards because I need them to be curly to fit into this space. I'd suggest you look at design for manufacture if that's your actual reason, but perhaps you do need to make fasteners that are specific to what you need to do. The difficulty is going to be where you have those things, such as in this example of automotive and aerospace needing tracking of everything right from the back end to when you put them into your product. Have a think about what software and systems you are going to need if you need to track things through a supply chain. Perhaps you don't need to do that piece yourself either, because there are companies who will help you ensure that you can track things through a supply chain. So my advice would be to have a look at it holistically. No individual part should determine everything that you do, but you should be able to figure out a holistic way of when it makes sense to make a thing. I can almost guarantee that for the vast majority of semi-standardized parts, it's going to be cheaper and more efficient and easier to track if you buy it from experts than try and make it yourself. If it's something that is specialized and really core to your product, it probably makes sense that you're making it in-house.
Thank you. Bill, I hope that answered your question, but if not, or you need a bit more background, feel free to reach out. But just said thank you there. So, look, if there are no further questions, we might give everybody back 10 minutes in your day. If we just go to the next slide, there is the ability for you to visit Michael's various platforms there. So feel free to scan. We'll go to the next slide. If you wish to connect with AMGC, please, there is a very simple way. It's connect@amgc.org.au. There are a range of experts in our network, such as Michael, who'll be more than happy and willing to assist you with a variety of challenges you may have as you move towards commercialising your product or processes. And again, that is available to Industry Growth Program participants. We will have a continued series of webinars with some interesting topics from a variety of speakers around your brand and how to access capital, amongst other things coming up. So please keep an eye on those as they're sent through to you from the IGP team. But if you would like to get in touch with us on a more one-to-one basis, please discuss this with your business advisor, and we'd be more than happy to help. But thank you for attending. We appreciate your time, and we look forward to having you on one of our webinars again soon. Thank you.